All right, so we're looking at quadratics, which is definitely something you guys should have a lot of experience with from Algebra 2, and then some of the stuff that we've been doing here lately with all the the transformation, stretching, reflecting, um, whatnot has been to be useful here too. But not a lot here that you guys shouldn't have experience with. Um, of course, with the quadratic, we have our parabola as the shape of our graph. We have the vertex, which is the turning point or the highest or lowest point of that parabola. Okay, that most important point would be your vertex. Of course, the axis of symmetry, that imaginary line that we draw through the graph in order to help us see things. Okay? So it's not actually there, but we draw it there to help us. The y-intercept, of course, the y-intercepts are important or defined by where x is equal to 0, and all parabolas will cross the y-axis at some point. Okay? X-intercepts, where y is defined as 0, right? And not all parabolas cross the y-axis, x-axis. So we'll get there to the ones that don't later, but say it shouldn't be a problem. And then normally we'd ask you guys to, in a normal year, we'd ask you guys to plot 5 points in order to have a good graph. With what you guys are doing on the WebAssign, it won't be necessary that once you have probably 3 points plotted, or figure out where they are, you'll have enough to kind of pick out from the lineup which one is the right graph. So, but that won't be as big a deal this time. Standard form, or what was written here, is called polynomial form, is ax squared plus bx plus c. This book calls it general form for some reason. I've never seen it called that, and I don't really like that, but I just want you guys to know that, so when you read that, you know what they're talking about. When they say general form, they mean standard form. The really crappy thing is that later on when they say standard form, they're talking about vertex form. So watch out for that. So again, I'm not very happy that they chose to change that language. So that's our general form, our standard form. Then they go into start talking about how to find the axis of symmetry and about where this formula came from. That by using the quadratic formula, we're able to figure it out. It's just a part of this. And you guys will need the quadratic formula later, so I'm just going to go ahead and highlight this. But that's definitely something you guys should have memory of doing last year in Algebra 2. So I'm just highlight that. But how do we find the axis of symmetry? Here's the equation for that. This is an important equation. Okay. That's how we find the equation of that line, right? It is a vertical line, that's why it has an x equals, right? So x equals, and then whatever the value of this is, negative b divided by 2a. So using these values here from the function. Well, if that's where the axis of symmetry is and the vertex is always on the axis of symmetry, that means it has the same x-coordinate, right? So the x-coordinate of the vertex is there. Well, how do we find y-coordinates, right? We need the y-coordinate. Well, same way we've always found y-coordinates, by putting the x value back into the function. So you find the x value of the vertex by using the axis of symmetry formula, and then you plug it in to the function, and that will give you your y value, which is what this is trying to say. I just think it's an overly complicated way of saying it. Here's the value for x, and then you take f of that, right? When we say f of, that means a y value. So there would be our y value of our vertex. Okay? Find x, plug it in, then you'll have y. Okay? X-intercepts. Again, those are when y is 0. Okay? So what we end up doing is taking the equation and setting it equal to 0. We take our y value, which our f of x value, not f of 0, but the whole thing becomes 0. And then we need to solve for x. How do we solve for x in that case? We can use the quadratic formula, or we can factor, which is really going to be your best bet. But if you can factor it, then factoring is going to be a lot faster than using the quadratic formula. That needs to be where you start. Again, some problems have 2 x-intercepts, some would only have 1, and then some won't have any, just depending on what the graph looks like. It may not cross the x-axis at all. May only touch it once, may touch it twice. Okay, again, we're going to focus on the ones that do have x-intercepts right now. We'll get to the ones where they're not real later. And a y-intercept, of course, that means that x is 0. Okay. Well, if x is 0, that means if I just use this problem as an example, if x is 0, well, I'd have 2 times 0 plus 5 times 0, which all of this would be 0. So that means my y-intercept is this. So I think this is a little bit overly complicated. Your y-intercept is 0, c. So whatever your c value is the y-intercept. So we're going to go through a couple examples where basically what the homework's going to be like is there'll be some problems where they'll ask you to find the vertex and the axis of symmetry, the x-intercepts and the y-intercepts, and then pick out a graph out of a group of 4. And then there'll be separate problems to say, hey, find the min or max value of this function, or hey, find the domain and range of this function. I'm going to do all of it as one big problem and just talk to you about how would you pull out those little sections and say if all you had to do was find the domain and range, how would you do that without having to do all the other stuff? So, okay, but we're just going to look at a couple problems where we do all of it, and you can know how to do the parts. If it just said do this part or do that part. Does that make sense? Okay. All right. So now I need to kind of move off into like a blank side of paper. And I would kind of have a space on the left side where you're going to do your work, and then leave space on the right side to put your graph. Okay. I'd imagine by the time that we're done with this is probably going to take up about half a page of paper. Okay. You may not want to lay it all out right now because you don't know where the spacing is going to be for you. I've done it enough where I know how much space it's going to take me. Okay. And we aren't necessarily going to do these things in this order. I'm going to talk to you about maybe a smarter way to do it. But this is generally the way it was ordered in the like on the web assignment. So I just wanted to show you this way. Okay. But here's the function that we're going to graph it. Okay. We're going to find its vertex. We're going to find its axis of symmetry. We're going to find its y-intercept, its x-intercepts, its min, its max, its range, and main. I don't know if you guys need any time to kind of get yourself set up. If you need me to wait a minute. Or if you're ready to go. We're just good to go. All right, we're just good to go. So, all right, we get to answer the questions in any order we want. Why would we start with the harder questions? Right? Start with the easiest one. Absolute easiest thing to know when you look at a quadratic function in standard form or general form is its y-intercept. So I would start there. Okay. Y-intercept is always your c value. Should always be the constant. Should be at the end of the problem. Right? Well, this does not have a c value. Right? There'd be a little +0 there if we did that. So y-intercepts, the x coordinate is always 0. Well, our y coordinate for this problem is also 0. Okay. Starting with the easiest thing, that. In order to find the vertex, we have to know the axis of symmetry first. So I have to do this step before I can go and do this step. Okay? So that's where I'm going next. Okay. Well, the axis of symmetry is a formula. X equals -b/2a. Okay. Do you need to go back and write down what your A, B, and C are? Okay. Some people do. Sometimes it helps people. Okay. In this problem, my A value is 1, my B value is 4, my C value is 0. Okay. So maybe doing that is helpful. It's a really simple formula. I can't tell you how many times I've seen people mess it up. Negative something over 2 times something. I think there's a higher likelihood that you won't mess it up if you do this, like kind of create little shells. Okay, I know it's negative something and 2 times something. What are my somethings? Especially when like b is negative. I've seen people really screw that up. Okay, my b value is 4, my a value is 1. So that gives me negative 4 over 2, which of course is negative 2. So there's our axis of symmetry. So we know where it crosses the y-axis. We know where the middle of the graph is now. Okay. Remember that somewhere on that axis of symmetry is our vertex. Okay. So we know the x value of the vertex. That means we're going to take that x value, we're going to plug it in. So we're going to say, what is f of negative 2? So we take negative 2 and we square it, and then we take 4 times that. Nothing that complicated here. Right? Negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. 4 minus 8 is negative 4. So that means my vertex is at negative 2, negative 4. So there's our most important point of the graph. Okay, so now we know that. Realistically, at this point, we have enough information to plot that information and then go to pick out the graph that would be the right one out of the group. Okay? They're still asking us to find the x-intercepts, so we're still going to go do that before we go and do the rest of it. Okay. But again, at this point, with knowing those 3 things, we should be able to pick out the right graph. Anything about this stuff? This is the easiest stuff. Is there anything here before we move on to find the x-intercepts, which is generally the hardest thing to do here? You good, Tiger? You good, Katie? All right. So let's look at those x-intercepts, right? So if it's a y-intercept, we know that x is 0. If it's x-intercept, that means that y is 0. Okay? Well, where's our y? Right? Remember, y is the f of x part. So it's not f of 0. It's the whole thing is 0. Okay? So 0 equals x squared plus 4x. Then we need to solve for x. Okay? In order to solve a quadratic equation, we use factoring or we use the quadratic formula. What's the most basic type of factoring we should be trying to use? It's the first type of factoring we should always try. GCF, right, Maddie? So is there a GCF, Maddie? They don't have anything in common?
I don't think so. I mean, because it's
Caleb's
one.
trying to help you out there.
Huh?
Caleb's trying to help you out in the chat there.
Oh, x.
So x times what, Maddie?
X plus 4.
Okay. So there it is factoring, right? We were able to find a GCF. It's factored now. We don't have to do anything else. Okay. So at this point, now we solve. We factor so we can solve. We set each part equal to 0. Well, that was easy. That wasn't too bad either. All right. What did we know about these? That y was 0. So we knew y had to be 0. It was our job to figure out what x was in order to make y 0. So here's our x-intercepts. When they ask you to put those in, they always seem to ask, like, they separate them. You couldn't just type them in willy-nilly. It's always said type in the small one first and then the big one second and the larger one second. So in this case, you'd have to type in negative 4, 0 first and then type in 0, 0 second. Okay? And it does say right next to it, like, smaller one, larger one. So you need to pay attention to that. Okay? So there we have all that. So now that we have all that, let's go ahead and graph it. Okay, again, we could have done this earlier and picked out the right graph at that moment, but so we had our y-intercept, which was 0, 0. Turns out one of our x-intercepts was also 0, 0. So anytime a y-intercept is on the origin, one of the x-intercepts has to be on the origin. So that was kind of, so that's something you can use to make things a little easier on yourself. But, so there's our axis of symmetry. We found our vertex, right, -2, -4. And so why I said that we could have been done earlier is that once we have our vertex and our axis of symmetry and then one other point, we have enough information to go ahead and just reflect that point over, right? This is a symmetrical picture. There should be another point here. And so we actually could have found the x-intercepts this way, but that only works for this exact type of problem where it looks exactly like this. So all the other problems, they don't do this, so it's not really worth like memorizing, okay? But in just kind of making note of it. So what I'm saying, we could have picked it out because from the graphs you guys are have, there's going to be like 1 or 2 that are opening down. There's going to be 1 or 2 that are opening up, right? And this one obviously opens up, okay? And then one will be like over here instead, right? So we could have had enough information to pick out the one that was right already. So, yeah, so here's our graph, right? From the information we have. And normally if we were in class, I would be saying you guys need to have 5 points, okay? And right now we only have 3, so I'd say, well, okay, you got to find 2 more points. And so what that's all about is, we know if x is 0, we know the answer. If x is -2, we know the answer. If x is -4, we know the answer. Well, what don't we know the answers for as far as x goes? Well, what's happening at -1 or what's happening at -3? Okay, I don't really care what's happening over here at like 6 because that's too far away. You want to stick near the vertex and say what's happening around the vertex, because otherwise the numbers get way too big, way too fast. Okay, so you plug in like -1 and get an answer and then flip it, or you plug in -3 and get the answer and flip it. Okay, so that's what I'd expect if you guys were here doing this by hand. But since you get to pick them out of a lineup, it's a little bit easier. So you're going to be looking for a graph that looks like this. Okay. Anything about that you guys got questions about? So, once we have the graph, finding the min and max and domain and range pretty simple because it's very visual. But when you guys are doing this in homework, it won't ask you to do all this other stuff and then find the min and max. It'll give you the equation and say find the min or the max of this equation. So how do you do that without having to graph it? Because doing all the graphing stuff takes quite a bit of time. Okay. So let's talk about how you would find it with a graph, and we'll talk about how you would do it without it. Okay. So does this graph have a minimum or a maximum? Okay. Well, there's one thing that controls that, and that's the sign of A. Right. Just like we were just talking about with all the reflection stuff. If your A value is negative, that graph that was supposed to open up now all of a sudden opens down. Okay. Well, if my graph that was supposed to open up has a bottom, aka a minimum, and the graph that opens down would have a top, aka a maximum. So by looking at the sign of the function, you can say if it's a min or a max. Since that's positive, our graph will have a minimum. Okay? So you don't actually have to graph it, you will just know that. Okay? But because this is positive, this will be a minimum. If that was a -1, then that would be a maximum. Okay? Now, what is that minimum value? Okay. Well, the lowest value that it hits is -4. Where did we get that -4 from? Right here. That's the y value of the vertex. So it's a minimum at -4. Okay. So how could we figure that out without graphing it? So what I'm paying attention to there is that this opens up, or A is greater than 0. Okay, it opens up. And then this is the y value of the vertex. So in order to find the min or the max, you're going to have to find the y value of the vertex. And there's really only one way to do that. Find the axis of symmetry and then plug it in. Okay. If A had been less than 0, right, aka opens down, then that would have been a maximum. It's still whatever the y value of the vertex is. Okay, so A switching to be negative just changes that it's a maximum. You still find it the exact same way. Okay. Any questions about how to find a min or max without having to go through and do all the graphing? You can go through and graph it if you want to. Nothing's stopping you. It's just going to take you a lot longer. Okay. Thank you, Ruth. Okay. Domain, go back to your toolkit functions, or you look at the graph, right? Domain, this goes left forever, goes right forever. So this is always all real numbers. So if you're ever asked to find the domain of a quadratic function, easy peasy. Okay. Range, there's really only two options. Either it starts at some point and then goes up forever, or it goes down forever and stops at some point. What controls that? That's the sign of A again, right? This graph is a positive A value, means it goes up forever, means it has a lowest value. What's our lowest value? We just talked about that. That was the minimum. -4 was our lowest value, and then it goes up forever, okay? So there's our range. Make sure you put a bracket on that -4. If A is greater than 0, it will look like that. You just need to figure out what that y value is of your vertex. Okay? If A is less than 0, again, if A is greater, if A is negative, the graph opens down, goes down forever, and then stops at a highest point. Whatever your y value is, bracket. Okay? So if I just took this graph and just flipped it upside down, I would have put a -4 there. Okay? So again, if I want to find the range of the graph, if it just gives me a function, it says find the range of this, I could sit there and I could graph it out and then look at it. Or I could say, hey, what's my A value? Oh, it's negative. That means it's going to be pointing down, so I'm going to have a negative infinity. I need to find my y value of my vertex. Use my little absolute or my axis of symmetry formula, plug that in, gives me my y value. Okay. So it's up to you guys how you do that. Okay. Just a couple different ways to think about it. One's a little bit more thinking, the other one's more doing. Okay. I'm gonna do another one of those with you guys. Okay. Anything particular you want me to run back over in more detail, or it seems a little stickier than the other parts? You need a coordinate plane or anything, Cole? Do you need a coordinate plane or anything? I have a bunch. Do you need a coordinate plane or anything? All right. No, let's do it again. Here's our function. Everything else is the same. That was silly. So Piper, what's the first thing we should try to find? What's the easiest thing to find? Angelique, what's the easiest thing to find? What should we find first? Vertex isn't the easiest.
The greatest common factor? No? Okay.
No. Katie, what's the easiest thing to find when we look at the problem?
The y-intercept?
Y-intercept, where's our y-intercept?
I don't know, but x is 0.
X is 0. Where's our y-intercept, Piper? Victoria, where's our y-intercept? Riley? Be a good thing to put in the chat, Riley. Jaden? Yep, these would be good things to type in the public chat, guys, not the private chat. Rhea, all right. How'd you know it was 11, Rhea?
It's C.
Let's see. Right there. Yeah. One number, grab it. Okay. Now, Piper, if we want to find the vertex, what do we got to do first?
Can you repeat the question?
If you want to find the vertex, what do you need to do first?
We'll need to find our x integer.
Yes, our x value. All right, Riley, the axis of symmetry. Okay. What's our formula to find the axis of symmetry? All right, cool. Negative b over 2a. Yeah, so make sure you know your a value, your b value. So negative 8 over 2 times 1, which that's negative 8 over 2, which is equal to negative 4. Okay. X equals negative 4. That's an equation of a line, so you do need to write it as an equation. It's not okay just to say 4. Okay. So now that we have that, we go back to the function, we plug that in. Oh, Lord, come on. Sorry. One day it'll... No, it won't. Why am I lying? It won't work. So we're going to find f of negative 4. So negative 4 squared plus 8 times negative 4 plus 11. Negative 4 times negative 4 is positive 16, not negative 16. That gives me negative 32 plus 11. Negative 16, or 16 minus 32 is negative 16, plus 11 is negative 5. That means our vertex is at negative 4, negative 5. Again, at this point, we really do have enough information to graph it and pick out the graph out of the group. Okay, but we're still going to need to find the x-intercepts anyways to finish the problem. Okay. I'm not saying you have to do in that order. You don't have to find the y-intercept first, but it is the easiest thing, so might as well start there. You have to find the axis of symmetry before you can find the vertex. There's no choice there. Okay. So x-intercepts. All right, we know that y is 0. That means 0 equals x squared plus 8x plus 11. What's the first thing we try in order to solve this? Where do we start with this? What should we try first, Jordan? AC method, something we should try, but not necessarily first. Yeah, we'll look for a GCF first, right? Because it's quick. If it's there, then we're done. And is there a GCF? Right? 1, 8, 11. Nope. Okay. So it doesn't work. All right. So yeah, then we go to AC method. Okay. Well, what's our AC? Well, A is 1, C is 11, so our AC is 11, and we need that to add up to be 8. What are our factors of 11 that could add to be 8? Well, 1 times 11 is the only factors of 11. No way to get 8 out of that. So AC doesn't work. Okay? So you guys are going to have one problem that's going to be a GCF problem. You're going to have one problem where the AC method will work, and then you're going to have one problem where it doesn't work. So what do? That's when you bring out the big gun, which is the quadratic formula. I'm going to write that down again, but you guys should have that in your notes already. Negative b plus or minus b squared over minus 4ac over 2a. Okay? Again, your a, your b, and your c. Okay? So make sure you're pulling those out correctly. It's all just plugging in and then simplifying. So b value is 8 plus or minus square root 8 squared minus 4. It's always minus 4 times 1 times 11 all over 2 times 1. Remember last year a lot of students were not putting the fraction bar under this. Right? So this needs to have the fraction bar underneath it also. Make sure that ends up there. Right? The rest is simplifying. Okay? You're just following order of operations to do this correctly. Okay? I can do the negative 8 plus or minus square root 8 squared is 64. Now the next thing I'm going to look at here, I'm not going to try to do the math yet. I'm going to look at the signs. And the thing about it is that that's a negative sign. Okay? I have a negative times 2 positives. Well, negative times 2 positives is going to be a negative. If this had been a negative 11, then I'd have 2 negatives. Right? Then I would write a plus sign here. So I'm just thinking about the signs. Right? That's all I'm doing right now. I have 1 negative. That means my answer is going to be negative. Now I don't worry about the negative anymore. That's 4 times 1 times 11. Oh, that's 44. Okay? Seeing a lot of students mess up having multiple negatives there because they don't pay attention to that, or they try to do minus a negative or something like that. Just think about them all as negatives. What's my answer? Oh, it's positive, or oh, it's negative, and then just write that sign there. Then go and do the math. Okay? All over 2. Now we're finding x here. We're solving for x. Don't let that x equals just drift off. It's not okay. Just can't divide yet. Okay? Got to finish simplifying. 64 minus 44 is 20. Okay? You can't divide yet. You're not done simplifying. How do we simplify the square root of 20? How do we simplify the square root of 20? Right on, Maddie, sock method. Okay. Square root of 20, 2 times 10, 2 times 5. It's called the sock method because we have a little sock. Okay. The 10 and the 20 are dead. What do we do now that we have it all broken apart? Socked it out. What do I do now?
You find a pair.
Pair? Okay. And then we worry about our little lonely guy. Okay. So negative 8 plus or minus. If you've got a buddy, where do you get to go?
You gotta go outside.
You go outside. If you're lonely, where do you go?
Inside.
You stay inside. Yeah. Pair of 2's goes out. Lonely 5 stays in. 2 times the square root of 5 is equal to the square root of 20. Okay, we've simplified it. We've reduced it. Okay? Now we can divide. Okay? Now we reduce. If you do it too early, you're going to screw it up. Okay? It is the very last thing you get to do when you're simplifying quadratic formula. Okay? Can I reduce this? I'm looking at all three things. Okay? I'm not looking at this because that's a radical number. I don't care about it. Okay? I'm looking at all the normal numbers. Do they reduce? Okay? They all have to have something in common in order for that to work. They all have a 2 in them that I can take out. It becomes -4 plus or minus. That 2 becomes a 1. The square root of 5 is still there. This 2 also becomes a 1. So those just go away. There are x-intercepts. Okay? But just like before on the last problem, they're going to want you to write them in a certain way and in a certain order. They're going to want you to write the smaller one and then write the larger one. Okay, so it's going to say smaller, and it's going to say larger, and it's just going to be I think they put the parentheses there for you already. Okay, but you got to fill them in. Well, what do we know about all x-intercepts? Right, we know that y is 0. So now I need to look at these two numbers, right? There's two numbers here, not this number and that number. Within all that, there's two numbers. Which one's smaller? Well, a number minus another number is always going to be smaller than a number plus another number. Okay? So the smaller of the two is -4 minus the square root of 5. That's how you're going to type it in. Sorry. And then the bigger of the two would be -4 plus square root of 5. So there are your x-intercepts. Okay. You guys will have one problem like that. So you have one where you can do the GCF to solve it, one where there's AC method to solve it. There's one where you have to do quad formula to solve it. Okay. Anything about the quad formula you guys want me to go back over? It's been a while. I know we haven't done that together. But, it's definitely something you did last year. That's been a while. So again, back after we had the y-intercept, we had enough information to graph it and pick out the graph, okay? So I'm going to use that to kind of talk about what the graph should look like. Of course, our axis of symmetry is at -4. And we found our vertex to be -4, -5. The y-intercept was at 11, so we can kind of figure out where that is. Up here at 0 to 11. Okay. That one's 4 away from the axis of symmetry, so if I go 4 on the other side, put a point here. Okay, we should be able to figure out what the graph looks like enough to pick it out of a lineup, right? It should look something like this. Opens up, it's on the left side of the graph, right? There's going to be one that opens down, you can get rid of that. There's going to be one that opens over here, right? You should be able to eliminate the other ones pretty easily, okay? That those don't make sense. What about those x-intercepts? What's up with those? Right? How do I talk about, say, hey, let's talk about 4 minus the square root of 5. Where is that? Okay. Well, remember, we know it's on the x-axis. Okay. The square root of 5 is like 2.2 something. Okay. So if I think about what -4 minus that would be, right? -4 minus 2 would be -6. -4 minus 2.2 would be like -6.6. Okay. So if we think about where that is, or sorry, 6.2, it would be right about there. Right? 6.2 is. And then -4 plus the square root of 5, which would be -4 plus 2.2. So -4 plus 2 is -2. -4 plus 2.2 would be like -1.8, which would be right about here. So my graph wasn't great. My sketch wasn't great. We can see that it makes sense within our sketch that that's where our x-intercepts would be. Of -4 plus the square root of 5 and -4 minus the square root of 5. Okay. That's where that crosses the x-axis. Okay. Again, the min-max stuff, the domain range stuff, those will be completely separate. Okay, so if I wanted to find the min or the max of this problem, I have to look at this first. I say, is my A value positive or negative? I say, oh, it's positive. It means my graph opens up. So I'm thinking about all this. My graph opens up. So that means it has a bottom. Opens up, it has a bottom. So that means my graph has a minimum. I don't need to see the graph in order to know that. Well, where is that minimum? Now I got to start doing some work. Okay, well, what's my x value? Where's my axis of symmetry? So I got to go and calculate that. Then I got to go and plug that in. So now I got to do some work. I can't just think my way through that. But once we do, we find out that the y value is -5. Okay? So you do those calculations to figure out that. A little bit of thinking, and then some work. Okay? So. Then we say, oh, well, if they just asked me the domain of that, they didn't ask me to do anything else. Oh, that's easy. I love domain questions because they're always all real numbers. Okay? What if they ask me the range? Ooh, I got a little bit of thinking to do now. Okay, does it open up or does it open down? Ooh, it opens up because A is positive. It means it has a bottom, has a lowest value. It means I need to know a number where it's going to stop, but I know that it'll go up forever. Okay, just by knowing that it opens up, it has to look like that. I just got to figure out what that number is. Okay? The same way I found it for the minimum, I have to figure out what my axis of symmetry is, and I got to plug that in. And once I know that the y value is -5, it means this bottom of the graph is -5. So you guys need to be able to find the vertex, okay, quickly, efficiently. The vertex is really important when we talk about quadratics. Okay. And understand how the x-coordinate of the vertex is one thing, right? It's the axis of symmetry. The y-coordinate is something else. It's the min, the max, the top or the bottom of our range. Okay? They both have their own pieces to play within the problem, their own importance. And then they come together to be the most important thing, the vertex. Anything about this you guys want me to go back over? It's a pretty big problem. Bruce feeling good? Caleb, you doing okay?
Yeah, I'm doing good.
Wesley, how about you? Jaden, how about you?
Yeah, I'm doing good.
All right. Okay. All right, just one last thing I want to show you guys. Okay. So what you're being asked to do here is I'm giving you a vertex. I'm giving you another point on the graph. We're going to be asked to write the equation of the graph. And this is pretty similar to something you guys have done a lot, which is given 2 points, write the equation of the line that goes between them. Well, here, of course, we want the quadratic equation that goes between them. So you guys don't need to write this down. I'm just going to quickly kind of sketch out the idea that if we know our vertex is up here at like 4, 7, then there's another point over here at like 2, -1. Because we know this is the vertex, there's only one graph that will go through that vertex and that point. Okay, there's only one particular function that will do that. Okay, if they had just given me any 2 points on a curve, said, hey, there's a quadratic equation that goes through these 2 points, there would actually be like an infinite number of curves that we could draw through that. Okay, so it has to be very specifically told us that one of those points has to be the vertex in order to make this process simpler. Okay, so because we know that, again, we can find that one particular curve that is doing that. Okay? So when we do it with lines, what we do is we give you guys 2 points and we say, hey, find the slope, and then once you have that slope, you put the slope into point slope form and one of the points, and then you work it down to slope intercept form. Right? We need to do something kind of similar with this. What we're going to use to help us is vertex form, or what this book calls standard form, unfortunately. But this is the one that we've been kind of talking about with all the shifting and stretching and stuff. Here's the vertex form of the quadratic. So you guys should be pretty familiar with this, and it's one we use quite a bit when we're doing quadratics. last year, in Algebra 2, so it should not be anything foreign to you guys. Now, why we use that is because it talks about h and k, right, which is the coordinates of the vertex. Well, I know my h value, and I know my k value, and they also gave me an x coordinate, and they also gave me a y coordinate. So we know all of that stuff. What we don't know is what a is. So our job first is to find a. Right? Just like if I said find it for a line, we'd have to find the slope. Well, here we have to find a, which remember a controls how much it curves. So whether it's skinny, whether it's fat, whether it's upside down, whether it's right side up. Right? It's kind of like the slope of the graph, but it's not in slope. Okay? It's like it. So our job is to find a first. So we're going to plug all those numbers into the form and solve for a. So just watch your signs, okay? It says y is -1. I can't use this y coordinate because that's k. Okay? I have to use the one that's just a plain old point. I can't use the vertex. I don't know what a is, times x, which I know what x is. X is 2. And it's always minus. And then, if this had been a -4, then I'd have to write minus -4. So watch your signs. Okay? But it's just y minus, or it's -4. Squared, and then it's always a plus here, and then if that had been a -7, then I'd have plus -7, or I'd write -7. So watch your signs. Okay. The first thing you do is plug in. Okay. And now it's our job to solve for a. Well, how do I solve for a? Right, I get it by itself. So if I'm thinking about that right now, I could say I can take that 7 and I can get rid of it. But I also need to think about how I need to simplify all of this stuff. I can't just get rid of this yet because it's not simple. So we are going to have to simplify this before we can get rid of it. But I can't simplify 7 anymore, so I can go ahead and get rid of the 7 if I want. Sometimes that's easier because it gets rid of some of the stuff on that right side. Makes it a little bit easier to look at. So I get -8 equals a times 2 minus 4 squared. So now I just need to simplify this. Okay. So in order to just simplify that, order of operations tells me to do this first. -8 equals a times -2 squared. Now I can square it. -2 times -2 is 4. I don't write a4, right? We write 4a. So 4a equals -8. So of course a equals -2. Arr. Oh man, come on. Okay. You guys understand how I found a? So once we have that, we're going to plug a, h, and k into vertex form. And we're going to simplify it down. So this is like when we plug the slope and a point into point slope form, and then we simplify it into slope intercept. So this is a kind of a lengthy process, but it's not really a difficult process. So we found a. Now we go back to our vertex form. So y equals a, which we just found. Let's switch colors here. And then our x minus, and then our h, which was 4. Squared, and then plus our k, which was 7. Our job is to simplify, which means we're following order of operations. Order of operations says go inside of the parentheses first. There's nothing for me to do in there. So then we go to the exponent first, next. Remember what squaring means. It means to multiply something by itself. That's x minus 4 times x minus 4, which is something I know we've talked about, and something a bunch of your math teachers should have talked to you about, how to square something appropriately. Okay. Now we can do any of that multiplication that we want. We can do any of this multiplication. Do not distribute the -2 everywhere. But I can take this multiplication, or I can do this multiplication. I would suggest you guys do the FOILing next. Okay, it's generally the easiest thing to do. So y equals -2, and if I do that all the way through, I'm not going to sit here and do it. You guys should know how to do that by now. Okay, get that. Now distribute the 2. Okay. The order I'm doing this is designed to help you guys do it correctly. So plus 16x minus 32 plus 7. And then the last thing is combine those like terms. So it's kind of a long process. It's not really anything that's too crazy difficult. Okay. So just take your time. I give you guys 2 of those to try. Okay, you guys got tomorrow to work on the assignment in class with me, which is always helpful if you got started and you know what questions you need help with. Okay. I'm getting a little frustrated with some of you guys just sitting here during class not doing anything. Giving you a whole hour to work on it and still not doing it. Just FYI. Too many of you are doing that.